In this video, we're going to build on a Jupyter notebook that we started in a previous video where we imported some stock data from Yahoo Finance. Now, we're going to add a bit of inflation data from the Bureau of Labor Statistics, and we're going to add that to our data frame with stock prices and see what kind of analysis we can draw, what kind of correlations and the like. This is a really powerful thing to do, and it's quite simple as well, and there's a lot of demand for it. We can get stock data very easily with Yahoo Finance, and then U.S. government data is typically freely available for use. And the U.S. government produces data on things like inflation and also the 10-year Treasury yield. So it's really easy to grab data and do some analysis where there is a bit of demand. So the only tricky thing is getting the data in a format that I could use. I went to the Bureau of Labor Statistics, and it kind of has the data in this two-dimensional table, which I could do a bit of manipulation on that, but nonetheless it'd be cleaner if I could just get a CSV file. So I went here and I chose column format, year range, 2014 to 2024, all time periods, untick include graphs, and then check by text and comma delimited and retrieve data. I was hoping it would just give me a file to download, but instead it just put the data right here. So what I did is I simply copied that and I created a new CSV file out of it, which we're going to import now. So I import pandas, which apparently I have not done yet, then do a PD read CSV. This is the name of the file where I pasted that CSV data. I'm reading it in as inflation. Now, a few things we'll notice here. First, we have a numerical index. We have 124 rows, which is roughly, that makes sense because we got about 10 years worth of data, give or take. Series ID is useless to us. We can likely drop this column. Year is going to be useful, and so is period, because we need a common index with our stocks. And take a look at our stock index. It's year-month-day, where day for monthly data is always going to be 01. So we can effectively make a new column out of it, but we have to grab the year, we have to grab the last two characters of period for month, and then we need to manually append the day. First, if I describe the data set, we'll see something a little bit interesting. Remember, describe is only going to show us the numerical columns because it's giving us things like mean, standard deviation, and the like. We see that value, which is effectively the inflation rate, is a number, not a surprise there. But so is year. And year is going to be a little bit easier if we deal with it as a string. So I'm going to reassign year here simply as year, but as a type string. So notice I have an equal sign, which means take what's on the right, execute it, and assign the result to what's on the left. I'm simply changing the type. Now, after that, it's a little bit easier to grab that year as a string and append the month to it. Let's work on that now. So we're creating a new column called date. We're setting that equal to the year as a string, plus a dash, plus the period, but look very closely at period. I have period, and then I'm saying treat this as a string. Start with the character at position number 1 and continue until the end. Now, what does that mean? Well, remember we start counting at 0 in Python, so the M is the character at position number 0. The 0 here is the character at position number 1, and then the 1 is the last character, so we're effectively grabbing the last two characters. This will work for us as long as the value in this column is always 3 characters, and the first one is the M, and the last two are the ones that we care about. If it were varied, if maybe we didn't have 0 padded months, we'd have to do a little bit more math, but because this is a fairly straightforward column, we can simply use that 1 colon to grab the entire day, entire month. And then we append 01 as the default day. So this is going to create a new column, and let's see what it looks like. 20140101, and if we take a look at our stock data and the index we're using there, it is indeed the correct format. So now that we have this new column that matches our stocks pretty well, let's go ahead and set it as the index on our inflation data frame. That looks really good. Now value, I want to rename that value column because I want to mix this column. I want to merge it with our stock data set, and value is not going to make sense then. So I simply assign the data frame to the data frame, but renaming the column value to inflation. Now, normally I would not have a column that's the same name as the data frame itself because that's ambiguous. It's also somewhat redundant. But I remember that the ultimate goal is I'm going to merge this data frame with my stock ticker data frame where a column name inflation is going to make a lot more sense. That looks good. Now, looking at this data frame, I don't have any use for series ID, frankly never did. Year and period is now redundant with the index date. So really, I can drop these columns that I don't need and make the data frame a bit more focused. I simply give it the drop command on the data frame, and then I can remove any columns that I don't want to have present. So series ID, year, and period. And now we have a very concise data frame. Really, it's really a series at this point that is the index is our date, and the value is the rate of inflation. If we happen to have a shared index across two different data frames, joining is really easy. And it feels right now like we're at that point. Okay, awesome. I have the same thing. But if we look a little bit deeper, we're going to see there's a subtle difference between the indexes on our data frames. Note that the monthly index data type, the index for the monthly prices, the data type for that, is kind of a weird less than M8NS, which means it's a date type. Let's take a look at the data type for our inflation dataset index. Well, it's an object, and these two things are a little bit different. So just as we change the type of the year column up above from a number to a string, I'm effectively going to force the monthly prices index to be an object as well. And no big difference visually, but there we have it. Now, let's look at the monthly price index values, which I can do simply by using that data frame name monthlyprices.index. We see that there's something that's been hiding from us here, which is a timestamp as well. And if we look at inflation, inflation does not have that timestamp. It's simply a list of strings that's the date. So we need to remove that timestamp so that we have an absolute identical index between these two data sets. That's actually not too hard to do. If we go back and look at that monthly prices index, we remember we have a little secret here, which is the value that we want are always the first 10 characters, and we can simply truncate anything after that. So I can simply say, okay, take this as a string, and then give me characters 0 inclusive through 100 exclusive, through 10 exclusive. Since we start counting with 0, that's going to give us characters 0 through 9, which is effectively that entire date. And once again, no change there. Let's just confirm monthly prices index. Looks how we want. Looks pretty good. Let's make sure that looks very similar to inflation index. And indeed it does. Very similar format with the dashes. D type is object, name is date. We're looking pretty good in both of these. So now we can join the two together, which is really easy once we've gotten to this point. So notice that we have monthly prices equals monthly prices dot join inflation, and now we see, sure enough, there we go, we have our inflation data. So it's a very easy way to join that in. Although I realize now that the data's not exactly what I want, because we have a price, which is effectively a cumulative value, and then we have inflation, which is effectively a month-over-month value. So I'm going to make a new data frame based off of this with a little bit of magic to compute the month-over-month change of these stock prices instead of the absolute price. I'll need to re-add the inflation data, so I will tell you this computation is going to look goofy with inflation, but that's okay. I'm going to overwrite that in a moment. To get the change month by month, I can use a built-in function for data frames called PCT change, which just says, okay, what is the change in this row, in this column, from this row to the previous row? And it gives me that change month over month in this case. So if we look here, we see numbers that look like about a monthly change. So we'll say that Apple went up by about 4% in the month of February 2019. Yeah, not a big surprise there. Looks like May was a bit of a down month, but nonetheless, these look like percentage change numbers month by month. Now for this, I can simply go back and rejoin my inflation. So I use this new monthly change data set that we've come up with here, the month over month change for each stock. And I'm going to just delete the inflation column. That way it won't tell me I'm trying to overwrite something or I've already joined something. Then after that, I redo that join statement I did above, only this time instead of joining inflation on monthly prices, I'm joining inflation on monthly change. And then I print out the monthly change, and here we go. Now, one thing that works out fairly nicely here is the scale. Most of these are right about in a similar neighborhood of numbers. So we don't see anything that's like 100 or 1,000. We see it's usually a plus or a minus, and then a 0 point, and then oftentimes a 0 and another number. So they're right about the same scale. But nonetheless, we now see we have inflation next to our other symbols. And that will cue us up well for our next video, where we're going to take a look at some line graphs of these symbols, and also a scatter plot matrix and some correlations to see which stocks tend to be correlated with which other stocks, and what correlation does inflation have with a percent change in stock prices. So that'll be our next video. I look forward to seeing you then. Thank you.